Hope you guys are doing well. So, welcome you back in the MPLS training session. So, today we are going to talk about MPLS operations, MPLS applications, the different label distribution mechanisms, what are the different protocols which we are using, and what are the basic differentiation between the LDP and RSVP. So I'm expecting you don't have any doubt from the yesterday's session. If you have, we'll have a Q&A. At that time, you can ask your doubts from yesterday's as well as from today's session. So let's start, guys. So first of all, the MPLS operation, how MPLS works. So on top of we have routing protocol. Okay. So we still need the unicast routing to be enabled end to end for running MPLS. Unicast routing has to be there. Then below that we have FEC. So I already explained what is forwarding equivalent class to you yesterday, that when a number of packets, the number of hosts, the number of networks are treated in the same way, it is known as FEC, forwarding equivalent class. So then using the FEC and the labels, both are combined and create a forwarding table called LFIB. So based on the FEC entry in my forwarding table and the labels which are distributed using the label distribution protocol, both of them are combined and create the LFIB table, which is label forwarding information base table. And this table is actually going to be used by the MPLS packet to be get forwarded. Then below that we have layer 2 and layer 1 forwarding. So if you see on the ingress point, we have to do the routing. Okay, first of all we need to see the routing. Why? Because when the packet comes in, it's a IP packet. At the ingress point, when packet is coming in, it's a pure IP packet. So we have to do the routing lookup first of all to see that whatever there in the destination IP field, am I able to reach there or not? Do I have the route for it or not? Then after doing the routing, then I will see in my forwarding table that for reaching that destination, who is my next hop? Whomsoever is my next hop, what is the appropriate label for that? Okay, so that information will get combined, and then that packet will become a MPLS packet. So at the ingress point we have two lookups. First lookup is the IP lookup, where we are saying that okay, can we reach that destination? Second is the label lookup, what is the label for my next stop, and I will combine both of them and create MPLS packet and send to the next forwarding router. So the router on the core node, okay, you can see in the middle the router on the core node, which is also known as LSR. That router will receive the MPLS labeled packet. It will make changes in that label packet and send it across. Okay, so that router, all the core router which are also known as provider router, those router are only responsible of doing one lookup. That lookup is MPLS label lookup. So they will see that which is the incoming label and what should be the outgoing appropriate label for that. And when it reach to the egress point, label will get removed. So again two lookups. First label get removed and then it will do IP lookup, where is the destination attached, and then it is sending across. So at the ingress point and egress point, you can see we have two lookups. First the IP and then the label lookup. But all the provider, the core router, they will do forwarding based on only and only MPLS labels, not the IP. So they will do only one lookup. What exactly this label is? This label is actually a 4 byte field. Okay, So in which we have 20 bits which is reserved for label, 3 bits is called experimental bit, that exp. That experimental bit is actually used for QoS purpose. So if we are implementing QoS along with our MPLS, so everyone is aware of, we can deploy quality of service with our IP traffic. Similarly, we can deploy quality of service for MPLS traffic also. Same way we can do marking, we can do classification, we can apply different type of policies to the packet. So all these marking, classification, the policies, they will be taken place by use of the experimental bit. Then we have S bit, which is 1 bit field. That S bit is used as a bottom of the stack, set to 1 for the last entry in the label. So right now it does not make much sense for you. Why? Because we are talking about just one label. Later on, when we are going to talk about MPLS based services, when we are going to talk about MPLS based labels, at that time I will explain, we will have a stack of labels. Stack of labels means more than one label is in the packet. So when packet comes into the router will look at the outermost label. Who is the outermost label? Okay. So because we are actually having two types of label, one is transport and one is service. So service label I'm not going to get into right now, I will explain after further slides. So we are talking about right now transport label. So we may have more than one transport label. I will explain you in which case we can have more than one. Okay. So that also I will explain you. So in that case, I need to look into that S bit. S bit basically, if in simple words I can say, will tell me that A, is it the last label in my stack or not? Do we have any further more label which I have to look? So S bit states that is it the last label in the stack or not. Then we have the TTL, which is same as usual. Everyone knows it's a time to live. How hopes that particular packet will live into the network. So the main bit here, which we are going to play around right now, is the label bit. Label bit is something which will be getting swapped at each and every hop. Okay, and they will and as I mentioned, we have two types of label. So let me get into there. Then I will explain that which label is going to be swapped when a particular router receives that label. Okay. So before we proceed further, guys, to the MPLS applications, I would like to explain a small thing to you, that we have a few types of table. So let me take my pen here. So first of all, the table which we have is RIB, routing information base, which is nothing your routing table. Okay. Then out of the routing table, you will create fib. What is fib? Fib is your forwarding information base. So routing table will be created by the routing protocol. Fib is created in case of Cisco. We are using Ceph. Okay. So there can be some other protocol also by which I will create fib, which contains the forwarding information based on IP. So far, no MPLS in the picture. This is the story of IP only, because we have to have the IP protocol enabled first of all, then only on top of that we can use MPLS. So this is the story of IP. Then MPLS come into the picture. You used one MPLS label distribution protocol. How many types, which all protocols we have, I'll explain to you. So when you enable MPLS, you enable by use of one label distribution protocol. When the label distribution protocol get activated, it create one database. That database is called lib, which is label information base. This lib is contains the labels associated for each and every prefix for each and every neighbor. So as much as entries we have in our routing table, that much of labels we will get it. Okay. So for an example, I'm learning one destination y two hopes. So uh, I will receive two labels for the same destination. So when those label getting to me, but there is to only one best path out of whatever IGP parameter, I decided only one best path. But in lib, it will contain all the labels which are assigned. So as much as entry we have in the routing table, similar entries we will get into the lib table, because similar number of labels we will get. Then, because as I'm saying that in the lib we have all the labels received, but we want to use the label which is assigned to best path only, right? We are going to assign the we are going to use the label which is assigned to the best path only. Some of the guys, you may get confused, because yesterday I was saying that IGP was having issues, that why MPLS came into the picture. But guys, right now we are doing IGP based forwarding only. So whatever as per IGP, I will do the forwarding, but the forwarding is on with MPLS, not by the IP. Okay, I'll in the later on when we get into the reservation, traffic engineering, all these things, I will explain you how you can pick up a path other than your IGP. But right now, whatever MPLS will use, it's the IGP based path only. Okay, MPLS will use the IGP based path only, but the forwarding is by MPLS, not by IP. That is the differentiation here. Okay, so we have fib, in which I have all the best path, the forwarding entries is stored. Okay, and I have lib where all the database. So I will combine, I will take information from fib and lib, and I will create lfib. Lfib is your label forwarding information base. So I will get the best path information from the fib, that what all best path entries I have, and what are the associated label for those path I will get from lib. So by including the lib and fib entries, I will create a table called lfib. So when a MPLS packet comes in, it will look for this table. Okay, this is the best path, this is outgoing interface, this is the label which is associated to it. So okay, I will use that label and send packet outside. So I will explain you how this lfib table looks like, how this particular table is built up, and how the what information packet will look for. So as soon as we get more into the label distribution, I will explain that thing to you. So I guess this thing makes sense to you. We have IP, which is using IGP, which is using lfib, which is using MPLS, and how the tables are built up. Okay, so this so far makes sense. So now I'll proceed further to the MPLS based applications. So MPLS based application, we are right now going to talk about two. One is the traffic engineering, and the other one is your VPN. So traffic engineering is the same a thing which yesterday we were talking about, that okay, our IGPs will choose only one best path, how we can get a path other than the IGP, how we can do the reservation of any path. All these things will be based on the traffic engineering. Okay, so this is one of the major application of MPLS. Second is the virtual private network, VPN. So let me explain little bit in detail about these. So this is one of the example of the traffic engineering. Okay, so we have this network, one R1 and R2 are two sources, and R8 is the destination. So for what you can see, we have the that red dotted line, which is a voice and video application. Okay, and yesterday I told you voice and video application will require a path with the lower latency. Okay, so but IGP will do based on the cost. So these 10 are actually the cost we can assume. So when packet is moving from R1 to R8, it will add up the cost. So 10 plus 10, 20, 30, 40. So I'm getting cost of 40. So this will be obviously going to be the best path, and all the packet will be sent to this link regardless of the type of the traffic, whether it's a voice and video traffic, whether it's a data traffic, whether it's internet traffic, whether it's a FTP based traffic. So regardless of the type of the traffic, all the data will be sent out to this particular link in the basic IGP forwarding. But what I can achieve through traffic engineering, what I can do here with the help of the traffic engineering. So what I can do is, So if you can see here, voice and data, right now both are traveling via same link. Why? Because of the lower cost. So I'm getting 40 when R1 is going to R8, when R2 is going to R8, again 40. But if you see from R1, if I choose other path, is 10 plus 10 plus, let me, so when it go to R1 wants to go to R8 by other path, it's 10 plus 10, 20, then we have 30, 40, and we have 50. So the cost via this path is what? 50, which I am getting. And the cost via other path I am getting is 40. So IGP will prefer that. But my voice and data, both traffic is actually getting sent out through this link. I want to segregate. I want a path which is having low latency. So my this other path is actually having lower latency. So I want to use this path for forwarding of my voice and voice traffic. Okay, I don't want, but as my IGP was picking up due to lower cost, I cannot do anything. So with the help of traffic engineering, what I can do is that I can reserve this path, okay, based on my type of the traffic. So in our case, it's a voice traffic. So I can reserve this path by the use of the characteristics of the voice traffic. And this, whenever voice traffic comes in, R3 will forward this via this path. And when data traffic comes in, R3 will forward via this path, which is the IGP path. So this is the example which we can do by the use of the traffic engineering. We can reserve a path which is other than the IGP best path, or I can say IGP so-called best path. Okay, because it's not best for me. My need is to send the voice traffic. I won't be able to send the voice traffic. I'm not getting the optimized I can say output of my voice traffic. So it's not best for me. Why should it matters to me whether it's a best for IGP or not? As I mentioned earlier, also for the customer at the end, what is matters? Their application. So for customer, the matters is the application. So they have voice application which is not going good because of they are having higher bandwidth, but there are a lot of jitters. There are a lot too much latency on that link. So my voice traffic is not good. So, but with the help of the traffic engineering, even though there is a higher cost, okay, there are additional hops which are getting introduced, but still I can do the reservation. Why? Because that path is having much more lesser latency than the other path. So my voice traffic will go through best. I don't care how much cost it is going to be, because when we say cost is basically depends on the type of the traffic which you want to carry. It should not be based on one parameter. It should be based on the situation, I can say. So if I take an example, the layman example, if a guy wants to go to a particular destination, that guy may use may fly to that destination, may drive to that destination, may walk to that destination, or may go via ship to that destination. So he'll having so many ways. But regardless of the cost, regardless of the type, regardless of the time which is getting consumed, he need to see whether my need is getting fulfilled or not. Maybe he need to carry a good lot of luggage with him. Okay, he is having some cargo kind of thing, so he is having good lot of stuff with him. So he may fly, or he may prefer to go via ship instead of get drive. Maybe driving is damn cheaper than going via flying or going via ship, but I don't care. I need to make sure that my needs should met. So here my needs is voice traffic needs lower latency, so my needs are getting met when I use this path. So traffic engineering will allow me to it's give me the ability that based on my type of application, my nature of application, I can do the reservation. So I guess it makes sense to you. Now the other application is MPLS VPN. So we are going to talk about right now the L3 VPN. Okay, not much the L2 VPN. Okay, L2 VPN is the different story. I will explain that later on to you. So right now, this is one of the very widely used type of application of MPLS traffic, which is L3 VPN. Okay, so here we have forget about that VPN A, VPN B. We have two customer, yellow and green. These are two different customers, yellow and green. Yellow and green customer is actually having branches in one in Singapore, the other one is in US. So some of the branches in Singapore, some of the branches in the US. Now there is one common service provider. So let's take an example. I have AT&T. So AT&T is the common service provider which basically covers both the areas by their service. Now I took connection from AT&T, the bandwidth connection. I took connection from AT&T in US as well as in Singapore. Now I have I'm saying that, hey, buddy, I don't need internet. I need only my sites should be able to communicate with each other. Okay, so there are two types of things. One is ISP, one is SP. ISP is internet service provider who can provide internet services. Okay, one is SP, which is service provider, which is providing you the service for connecting your two sites, not the internet. Okay, so here my yellow customer wants to reach the yellow customer in US. The green customer wants to reach to the green customer to US from Singapore. Okay, they don't care about the internet service in this particular situation. So, but you can say by chance they are using same private subnet. It's a private IP. They can use same. No one is going to ask them why you are using it. It's a private IP. They can use. So, and they are saying, hey, route my private IP, route my private subnet to the other side. Why? Because it's just a connection. It's just a it's not an internet where I cannot go by use my private IP. I'm just connecting my two sides, so I want to use my private subnet. So here I have 10.2.0. The green customer all of a sudden is also having 10.2.0, and both are getting connected to the same router. This router is known as PE, provider edge router. So this router is known as PE, provider edge, which is the edge of the service provider. These routers, which at the customer is known as CE, customer edge router. The router in the middle, those router are known as P router. That means to say provider router. And here, this router is again the PE. So when traffic is moving from left to right, this will be the ingress and this will be egress. When moving left to right to left, they say they will should change their role. So there is no specific roles based on the ingress point or egress point. So we don't care which one is the ingress and which one is the egress. And this one is again the CE, the customer edge. So this site 10.2.0, this network, so yellow customer is sending advertising 10.2.0.0 subnet to this router. Again, green customer is also advertising same. So if service provider ask them to change their IP subnet, they should not change. They will say, okay, I will change service provider. Why should change my IP? They have millions of users. They will not be, it's not a visible solution that they can change their IP subnet. So they are using same. So this service provider needs to do something at their end. Customer don't care about it, but the service provider needs to do something at their end so that the green customer 10.2.0 should be different, and the yellow customer 10.2.0 should be different. And when they are getting advertised from entire my service provider cloud and getting landed to the destination, yellow should go to yellow and green should go to green. So I need to make sure that too. So my first job is that I need to segregate the IP subnet. Why? Because they are using identical IP subnets. I cannot have two IP subnets in my routing table which are coming from two different customers. So for this kind of setup, I hope that you understood the setup which I'm talking about. So for this kind of setup, the MPLS L3 VPN solution is announced, in which what they are allowing is we will use one service. That service is called VRF, virtual routing and forwarding. So this I will get into each and every integrity of each and everything when we go into L3 VPN section. I will show you this theoretical as well as practical both. But right now, so for your high level understanding, we have something called VRF. By the use of VRF, what I will do is here's 10.2.0.0. So this 10.2.0.0 will be mapped with an additional I can say tag. Okay, let's say X. This tag is came out from VRF. So 10.2.0.0x is yellow customer. Okay, the same thing I will do for my green customer also. So for green customer, it's same subnet 10.2.0.0, but this one is tagged with Y. Okay, and this is for green customer. So this is yellow, otherwise you guys can get confused in why. And this is green. So now I do have the same subnet coming from the customer, which is 10.2.0.0, but they have some tags which are assigned, which are uniquely assigned, and by the use of those tags I'm segregating them. So this one will get landed, get this particular tag. Similarly, when this lands to the router, will get his tag. So that mean to say what, that they are using their own different tags. So when I see the routing table on this router, I will have 10.2.0.0x, and the other entry is 10.2.0.0y. So there are two different entries, so it's okay, it's unique for me, and I will use those tagging on the other side also. So I will tag the same values, X for the yellow and Y for the green. So when they come up on the remote side, as they are having X and Y value tagged, so X will automatically send to yellow even though it's the same subnet, and Y is sent to green. So the routing decision is not made for the based on the destination IP. Why? Because destination IP may be same. So here the routing decision is actually made by the use of this particular tag, and this what we call this tag. This tag is known as service label. Okay, this is again one kind of label only, but that label is known as service label. Someone has unmuted, guys. Can you please mute yourself? It may disturb the other guys. Sorry for that. If you have anything, we will have a Q&A session. At that time you can ask your queries. Okay, so let's go back. So what is this? This is the service label. So now we have two types of label. One is transport label, is used for MPLS forwarding. Transport label, it is clear by its name itself that it is used for the transportation purpose. So when packet is getting transported, hope by hope, it will be transported by use of the transport label. Similarly, we have some other type of label which is called service label, and that service label will be used for identification of the service. So L3 VPN is a service. So this service label is actually assigned by this service for their internal identification, whatever type of identification they need. So in our example, they need the identification that who is yellow, who is green. Maybe in a different kind of setup, they need some different kind of identification. So transport label will be used for swapping the packet inside the MPLS core. and service label is used by the service for their own internal identification. So I guess this makes sense. So it's very high level, guys. Still, it's a very high level. We have so many things in the L3 VPN, so many integrities there. We will get into that when we reach to the L3 VPN. So we will do this theoretical as well as the practical, both. Now, MPLS label distribution mechanism. So guys, yesterday I have explained you we have IP and we have MPLS. So both are the data plane and they need the control plane. So IP have the control plane protocol with, as IGP, which are EIGRP, OSPF, ISIS, any of them, and MPLS is having different control plane protocols. So you can see here the first statement which I have stated here is label distribution is a control plane action. We are doing label distribution for setting up the control plane so that the data plane can use that labels which are distributed and send the traffic across. Okay, and it always happen in the opposite direction of the data plane flow. So guys, you need to understand this part. Control plane allocation is always opposite of the data plane flow. How? Let me explain you. So we have 1, 2, 3, 4. So these are my hops, and this is my data flow, data plane flow. My traffic is going in this direction, 1 to 4. So my control plane flow will be in the opposite direction. So control plane will be 4 to 1. Okay, data plane is 1 to 4 and control plane will be 4 to 1. So it will always be in the opposite direction. So label distribution is a control plane action. It always happen in opposite direction as the data plane flow. That's why the label distribution is a downstream action. So when we say label distribution is the downstream, it is traveling from at the end point, the end device to the first device. So it's opposite. Okay, so usually we go down, up to down, okay, upstream to downstream, but the control plane will be downstream to upstream and opposite. So let me get into there. When let me get into the label distribution part, then I will explain you how this will work in the opposite direction. So there are two major label distribution protocol, or we can say MPLS control plane protocol, which works on different label distribution mechanism. They have their own ways. One is LDP, which is label distribution protocol. Other one is the RSVP, resource reservation protocol. They have their own different characteristics, different working. It's up to you. Depends on the situation and need which protocol you want to use. You can use both, but they will have different set of configuration, different set of characteristics, different set of behaviors when they reach to the when they talk about the allocation. So let's see. So first of all, we are going to talk about LDP, which is label distribution protocol. Label distribution LDP works down. If you see the mechanism, it's a downstream unsolicited label allocation. Okay, the first one, the downstream unsolicited, is the label allocation. How the downstream unsolicited label allocation happens, guys? So I have a topology down here, you can see. So I have 1, 2, 3, and 4. These are the nodes. Okay, so understand this very carefully, guys. It's very important. 1111, it's my destination, which is attached to the R4. So I'm going to talk about only this destination. So my traffic flow, my user is sitting somewhere here. Here is my user is sitting who wants to send the traffic to the 111. Okay, and until this points it all IP, and from this point onwards it all MPLS. The forwarding before R1 it's all IP based forwarding. After R1 on, from R1 onwards it's MPLS based forwarding. So how the labels are getting allocated, then I will explain you how the data will be sent. So label, because the traffic data flow is from 1 to 4, so label will be 4 to 1. So first of all, 4 will allocate. Okay, it starts from the other side. 4 will allocate the label to 111 because it's directly attached. So there are two types of label: local label and remote label. So he will assign his local label is 16. Okay, don't worry about this 16 17 range. I'll show you on the furthermore slides how this range, from where this range has come out. Okay, so 16 is the range, 16 is the local label which R4 has assigned on 111, and remote label is none. Why? Because it is directly attached to me. Okay, guys, don't take this thing for granted. Okay, this label allocation, I'm explaining this to you for your high level understanding. When we are going to see actual label allocation, it may be a bit different from what I am explaining you right now, but you have to understand this first so that you can understand the actual label forwarding. So R4 is having 111, and it will be assigning 16 label as their local label for 111. Remote label? No. Why? Because it is directly attached to me. I'm not learning it from somewhere. It is my host. Okay. So no remote label. So he will send this information to his peer. How will he send this information? Is there some adjacency? Is there some neighborship between them? Yes, there is a LDP neighborship which will be built. So LDP will use TCP and UDP both, okay, on port 646. So I'm using this port number. Yeah, it was 646 only. So I'm using this port number and for allocating the labels from one side to the other, for exchanging the parameters, because I have to have something to transport. So I'm using LDP for transportation of the label. Okay, so he will send, hey, my label, I am assigning 16 to this. Okay, this information sent to R3. R3 says, okay, you are sending using 16, so I will put my remote label as 16. Why? Because my neighbor is assigning, so my remote side is assigning 16, and I also have to assign one local label for my neighbors, so I will assign 17 to it, and I will send this information. What information is traveling? 17. That, hey, I have assigned 17. R2 received, okay, you have assigned 17. We are going to talk about 111 only, okay, for reaching 111. So R2 says, okay, you have assigned 17. Let me put 17 as my remote label because I learned this label from you. I don't know about this. I learned it from you. I will assign my own label, which is 18. Okay, again guys, I'm saying don't worry about these values. Okay, sometimes these value may be same, may be different, maybe some other range, so I will explain that part later. So it will assign, first of all, it will assign 18 and put 17 as their remote label. Now he will send this information to the last node. He's saying, okay, you are assigned 18, so I'm putting 18 as my remote label, and I'm assigning 19 as my local label because I also have to assign one label to it. Okay, so my label allocation is done. This label allocation is actually control plane operation. So this is done. Until now, none of the packet has sent. How they know about 1.1.1? Based on the IGP. IGP is already there. This network is advertised. It's from IGP it go to the fib. What is the best path, and out of fib these labels are allocated. Okay, this is for this path. There may be some other path, let's say via this way. So there will be label allocation on this path also. Okay, so it depends on this router that which path they will pick up. I'm making sense. So let me erase this. Sorry. Okay, so label allocation is done. I guess label allocation makes sense to you. Now let's talk about the data plane forwarding. Now my packets are actually getting forwarded. So packets, as I mentioned, there is a user who is sitting here, just connected here. He will send, hey, my source IP is X and my destination is 1.1.1.1. The packet comes into the router. The first thing that the router will do is the IP lookup. Hey, am I able to reach 1.1.1 or not? Yes. Okay. Let me check the label entry. Where it checks the label entry? I explained in the last slide. It's LFIB. So you will see LFIB that, okay, for going 111, what is the label? So he's saying, okay, for going 111, the label which I learned from my neighbor is 18. Okay. For reaching 111, the label which I used from neighbor, because I need to rely on neighbor for sending the packet. So now 111 is tagged. Change the color here. So 111 is tagged with one additional field which is called label as 18. Now this particular stuff is sent to this router. Now this router receives 1.1.1.1 with the tag of 18. So now this router is not at all responsible for looking at 111. Why? Because if you remember yesterday I was talking about there are two types of forwarding. One is called IP to MPLS forwarding. The other one is MPLS to MPLS forwarding. So the first router, the ingress router is doing IP to MPLS. Why? Because IP packet is coming in. He is tagging up on top of it the label and send. So when he sends that to the remote side, the neighbor, he receives already MPLS labeled. So it is MPLS to MPLS forwarding. So I don't need to look into 111. I will straightforward look into the label value which I am having here, which is 18. So I will remove 18 and I will see, okay, if I receive 18, I need to use 17. Did I care about 111? No, I care about these values. So I'm saying that, okay, this is my LFIB table which says that if the incoming is 18, the outgoing will be 17. So I don't need to even think of, I don't need to even make any kind of decision. It's pre-built. 18 coming, put it 17 and send it across. So he will send the packet to his neighbor. Now his neighbor is receiving 1111 with the label of 17. Again, this router is going to perform the same action. He is having the label, the LFIB table ready, and that table is saying that if I receive 17, okay, what I need to do? The all thing which I need to do is put 16 at place of 17. So remove 17, put 16. This is called swap operation. So when I'm imposing 18 here, this is called push operation. Why? Because I am pushing the label to the IP packet. When I'm sending across and it has reached here, when the labels are getting changed, this operation is called swap operation. So 18 removed 17, 17 removed 16, sent to the end router. He says that, okay, 17, I'm receiving 17. So what my LFIB says? LFIB says that, okay, sorry, if I receive 16. So what my LFIB table is saying? LFIB table is saying when you receive 16, you don't need to use any label. You don't need to use any label. That means to say I need to do IP lookup. So as soon as I receive 16, I will remove 16, and as I don't have any remote label assigned to it, I will now look for IP. So this router is going to do the additional lookup now. Okay, this lookup we can avoid by the use of PHP. I will explain that later. So that now he is going to look up into the IP that, hey, whether where is our 111. So he's saying, okay, 111 is attached to my gig 000 interface. Okay, send it across. So now a basic IP, a normal IP packet is sent across to the out of the gig 111. Okay, so that it can reach to the 1.1.1.1 destination IP. So I guess it has clearly making sense to you how the control plane action is taking place and how the data plane action is taking place here. Okay, this is how the label distribution works. So let me go back. So as I mentioned, is downstream unsolicited. Downstream unsolicited means it is the label distribution is happening from downstream to the upstream. Unsolicited, why? Because everyone will send the label. Okay, there is no something someone need to ask. Okay, this neighbor, hey, I want label from you. As soon as they have the entry installed into their routing table, they will assign label. They will allocate a label to it. Okay, so that's why it's downstream unsolicited label allocation. The other is the retention. It is a liberal label retention. Liberal label retention means what? That for an example, assume there are two more hops which are connecting those two routers, or maybe they don't have good link, so their cost is not good. This is the preferred way to reach here. But so when 111, he also allocates a label for 111, he also sends the label for 111, he also sends the label for 111. So what this router will do, this router will cap all the labels in the label information based table. It will not use for forwarding, because which table we are using for forwarding? The table which we are using for forwarding is the lfib, but they are putting everything in the lib. So he's saying, okay, I don't have problem, send it me. Everyone will send label to all the labels will be put it into lib, and that they are stored into the lib. So whomsoever is the best out of it, okay, whomsoever the label or the path which is best, that label will be used into the lfib table. Okay, and the packet will be forwarded based on that lfib table label. So that's why it's a liberal label retention, that hey, all send to me, I will store into my lib. So in case this particular link goes down, I don't need to wait for the others to allocate new labels. I already have a label from this. So maybe after this will be the preferred path. So I already have the label. So I will take that label out from lib and it's stored into my lfib. And that entry will be used for sending up the packets now. So it saves my time. Okay, but yes, I will capting all the unnecessary labels which I may not need. But as it's a neighbor and he is allocating his ldp enable, so I will retain that. So that's why it's called liberal label. So downstream, why? Because it's going from down to up. Unsolicited, because everyone can allocate. Liberal label retention, whomsoever is allocating, I will kept them into the lib. I don't say that, okay, I will keep only this or keep only this, only best path. No. So this is the behavior how LDP works. Okay. Now let's talk about the other one. So other one is RSVP, Resource Reservation Protocol. RSVP works on the different label distribution mechanism. So the mechanism which RSVP is downstream and on demand. Okay, the label allocation mechanism which RSVP is using is downstream on demand. It's not downstream unsolicited. So downstream means the same way, it will be in the opposite direction, but it's on demand. You have to demand for the label. So RSVP is quite different in compare to LDP. LDP is okay, as soon as LDP enable, start allocating label. But in case of RSVP, you have to query the label first. You have to ask, hey, I want a label on for this prefix on this particular path. then only the label will be allocated. And it's a conservative label retention. That means to say, I will only keep the label by the hope where I have asked for. Okay, I will only keep the label for which I have asked for. I asked A for providing the label, so I will I will retain only the label by A. So if B and C trying to send me the label, I will not retain, I will not entertain it. There is only one label which I will cap in my label information base, which is the label from where I have demanded. It's quite different. You can say that, then why is that so? Why it's not like LDP? Because you can see its name, it's a resource reservation protocol. We are not using RSVP to forward MPLS packet. We are using RSVP basically for reserving a specific resource, reserving specific resources for specific type of traffic. So that's why we are using RSVP. So I'm not going integrity of this. So we will discuss later in detail when we talk about traffic engineering. We are going to talk about RSVP in detail. So I guess so far it makes sense. So that's all for the today. Tomorrow, now next weekend, we are going to discuss further more in detail. Now let's have a Q&A session. So you guys just post your questions on the chat window, okay? And I will try to answer them. So I can see one question: what is the inner label and what is the outer label? So outer label is the transport label, Vivek, okay, which we are using for transporting the packet. That label is allocated either by RSVP or it will be by LDP. The inner label is the service label, which is allocated by the MPLS application. It can be L2 or it can be L3. So in case of L3, we are using MPBGP. In case of L2, we are using TLDP. So there are different protocols which we are using. So I will explain that service label allocation mechanism in detail when we are going to configure the services. If a router has three interfaces, then it will send the same label via all interfaces. If it is one destination, I will allocate one label and send to them. If they are different in the different prefixes, different. So whatever prefixes I have, I will allocate label for them. Any other question, guys? In LDP, the labels are allocated automatically. What will happen if a router receives the same label from two different neighbors? It's okay. I will keep them. Why? Because there will be two different outgoing interfaces, two different next hops. So if he is sending me same label, it's okay. I will keep them, store it. So because there is an outgoing label, there will be only one best path, right? If I am receiving two labels from two different neighbors, and there should be only one best path for outgoing, so I will use whatever is the best. Either it's the same value or not, it hardly matters. Why? Because I have the appropriate outgoing interface also. Vakas, what is PHP? PHP is penultimate hop popping, which is allowing the second last router to pop the label instead of last router is doing. So in next session, I will get into the PHP in detail and I will explain. So it is penultimate hop popping. What is the first work for PE when it receives an IP packet? First of all, it will look for IP lookup. It will perform a IP lookup and see whether do I have the destination where I want to reach or not. If the destination is there, then the label allocation. So Prasanta, don't worry, you will get the recording of this session and you can review it as many times you want. And try to be guys on time from next session onwards, because I'm having back to back sessions, so it will be quite difficult for me to wait for long. Okay, if I'm running two routing protocol, then rib will be both routes. Yes, but there would be only one routing protocol which will be used. Why? Because they will be having a AD value. So whichever AD value is less, I will use that routing protocol. So I don't care the prefix I'm learning via 100 routing protocol, whatever routing protocol. Home server is having lower AD, I will prefer that. Yes, I got confused with LDP slide. All routers were assigned the labels. Yes, so all routers are assigning label because I am explaining right now at very high level, Vakas. Okay, so PHP I didn't add it here. Otherwise, if a guy is not aware of, maybe they get confused for with this. Okay, so that's why I assigned all the router to assign the label. Next slide, next session, I will explain how PHP works. Then I will correct this thing. What can be the reason if a LSP is down? There are many reasons, Vivek. The LSP is down. Maybe your transport label is not getting allocated, IP reachability issue, your signaling protocol is not activated. There are maybe many causes. So for this kind of questions, Vivek, when we do the hands-on, I will try to basically show you what all different kind of causes may cause a down of LSP labels is not received. So but troubleshooting, as it's a very subjective thing, so it will be depends on when you are troubleshooting which kind of setup it is. But I will try to show as much as I can based on my experience that okay, this may be the issue, this may be the issue, this may be the issue. I will try to show you. Yep, thanks, Vivek. So, any other question, guys? Thanks, Vakas. No problem, Vakas. But from next session onwards, please try to be join on time because, as I mentioned, I have back-to-back sessions, so I may not be able to wait long. Thank you, guys. Thanks for joining. Thanks for attending the session. You will surely get the recording link of it. Okay. So I think no more questions. Thank you, guys. Thanks for joining. See you in the next session next week, Saturday. Bye.